on sets. And the best thing to do about learning about sets is to try to figure out what they mean and what they are. And I'm going to use an example, all right? Now, I am very, very, very lucky, and I have two bicycles. And so I'm going to say, let P be the set of all my bikes. And I'm very fortunate. I can't stress this enough because I love bikes. And I have a mountain bike and I have a road bike. I'm going to say the set N is the set of all bikes that my neighbor has. Well, my neighbor has a road bike and a BMX bike. I know because I fixed up his BMX bike the other day. And so, really, the elements of a set are what's in the set, all right? So, you can see if I said, well, what do I have? You can just say, oh, well, the elements are a mountain bike and a road bike. Now, if I had two mountain bikes, I wouldn't necessarily need to write that unless I was going to be speaking specifically about each specific bike. But if I just said, what types of bikes do I have? I have a mountain bike, I have mountain bikes, and I have road bikes, right? I might have 500 mountain bikes and 500 road bikes. I don't, and I wish I did, but I don't. And so, but I wouldn't have to write that. I'd only have to write one each. Now, if I said, what's the union, right? And this is going to look like pun, but this means union. That means this union, what does, if I put my bikes and my neighbor's bikes together, what types of bikes do we have? Well, now our set looks like this. It's a mountain bike, road bike, and BMX bike. And once again, you'll notice that I don't write road bike twice because we're just saying, well, what types of bikes do myself and my neighbor have? Myself and my neighbor. Well, we have a mountain bike, road bike, and BMX bikes. So that's the union. If I want to know the intersection, that means intersection. It means what do we have in common? And this is generally done with a Venn diagram. And so if you're not sure what a Venn diagram looks like, it looks like this. This is my bikes, my neighbor bike. I have a mountain bike. My neighbor has a BMX bike, but we both have a road bike. So the intersection would just be road bikes. It's just what we have in common. Now, there is one other situation that I want to talk about very quickly. What if I said I want to know the set of all motorcycles that I have? Well, that I have. I don't have any motorcycles, so I might just do the open brackets with nothing in it. And that doesn't mean zero, it means nothing. It's the null set. And sometimes you can write it like this as well if you want. And that's just to say, there's no elements in there. I don't have any motorcycles. So the set of all my motorcycles, maybe I shouldn't just call it P, maybe I should call it M. The set of all my motorcycles would be the null set, because I have no motorcycles. Alright, now, these are examples of finite sets. The ones that were not the null set. The null set, or the empty set, as it's also called, has no elements. A finite set has some elements that you can count. So here you can see I have, in this example, I had 2 elements. And here I had 2 elements. And here I only had 1 element, but it still makes it finite. It is also possible to have infinite number of sets. Elements in a set. So for example, the integers, which we called before z, would be an example of a finite, or not a finite, of an infinite set. And as a matter of fact, the natural numbers, which we call n, is also an example of an infinite set. And at this point in time, you should be thinking, whoa, 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 wait a second. If the integers are infinite and the natural numbers are infinite, doesn't mean that there's the same number of integers as there are natural numbers. That's a whole nother discussion, and I will get into that at some other point in time, but I do want to just throw that out. What do you think? Anyway, the last thing I want to talk about as far as sets go is the set builder, and this is a little bit funny, right? So we can say the set A is equal to, and now what you'll sometimes see is, you'll see something like this, and then it'll give you some kind of rule, say, 8 is less than or equal to x, which is less than 10. And then it might say x is an integer. All right? And what this really means is, a is equal to the set, that's the set, you can tell because of this little set brackets, of all x's such that, this means such that 8 is less than or equal to x, and which is less than 10, given that x is an integer. So it really means a can only be 8 or 9, because 8 and 9 are both integers. 8 is less than or equal to x, 9 is less than 10, and that's it. That's all you have. It's a finite set, so it's very, very, very small. I'm going to give you an example, another example that is in the book. It says something like this. It says x such that x is less than 3, and x, this little symbol here means is an element of the integers, and x, and I am going to do this one more time, so if you're like, holy smokes, I don't know what on earth you're talking about, is greater than equal to -1, given that x is an element of the integers. So let's see what this actually means. We're going to take a look at this one at a time. So this one says the set of all values of x such that x is less than 3 and x is an element of the integers. So that's going to be negative, both dot, -2, -1, 0, 1, and 2. It doesn't include 3 because it's just less than 3. But then it says, and, this is the intersection and, remember that from before, and x is greater than -1, greater than or equal to -1, such that, given that x is an element of the integer. So I'm going to start at -1, 0, 1, 2, 3, dot, dot, dot. It goes on forever because it's all the values of x greater than or equal to -1. Now it says, I want to know the intersection. So let's see, what do they have in common? They both have a -1 in common. They both have a 0 in common. They both have 1 in common. They both have a 2 in common. So really, this whole thing, if this was called set P, we could just say P is equal to -1, 0, 1, and 2. And I am going to stop there. I highly encourage you to watch this video more than once. Preferably take a break, watch it again, take down some notes, write down some questions. All right, good luck.